Okay, so in 12.1, we talked about the trigonometry of a right triangle. Only a right triangle, meaning we haven't done anything bigger than 90 degrees yet, because in a right angle, the biggest angle possible is a 90-degree angle. But it's possible that we can find the sine, cosine, tangent, cosecant, secant, cotangent of any angle that you want. You can find the sine of a negative angle. You could find the cosine of an angle that's bigger than 360 degrees. You can find something that's bigger than 90 degrees, which is something that we haven't done before. So we call the other one right triangle trig. We call this coordinate system trig, or general trigonometric functions for general angles. So what we're going to look at is the entire xy coordinate system, not just a normal right triangle. So if we set up a nice coordinate system here, here's your x-axis, here's your y-axis, and then we know if our angle is in standard position. This is the initial side right here, sitting right on the x-axis. Here's the vertex of the angle, and then instead of just going into the first quadrant, which is are the only angles that we've talked about so far, it could go anywhere. So say your terminal side is here. So this whole thing right here would be your angle, your theta. Okay, so now the important part of things that are 90 or greater than 90 degrees is we've got this concept that we've used so far is Sohcahtoa, which involves a triangle. And if we're no longer inside of a triangle, we kind of lose where we're supposed to get the sine, the cosine, and the tangent from. So we're going to define them in kind of a new way here. So here's what we need. We need theta, which I just drew on right here, to be in standard position. And then we put this point, so like on our terminal side right here, we put a point on there and we call this point xy. It's got a coordinate point, it has an x coordinate, it has a y coordinate. So we say this point with the coordinate point xy, so we label the point P, is a point on the terminal side. All right, so then here's what happens, because like I said, we're most comfortable when we're dealing with a right triangle. So what we can do is we can still kind of, sort of, make a triangle out of the angle that we drew in the third quadrant. And when you're looking, so you've got this x value, this would be the y value, and then this diagonal right here, we label that r. Okay, so we label that r, and we find that by just doing the Pythagorean Theorem with the x and y value, and we'll see that in our next example. So here is how we are now going to define the general angles, trig functions. So sine of theta is going to be defined as y over r, which is actually quite similar to opposite over hypotenuse, because this line right here is the y value and then r. So it's kind of like opposite over hypotenuse. And then cosine is defined as x over r, which again, if this line gives you the x value, this is kind of like the hypotenuse, I suppose. So it's similar to adjacent over hypotenuse. And then the last one, tangent, again, is similar to the way we defined it before. This time we define it as y over x. This is the y value, this is the x value, very similar to opposite over adjacent. And then we've got the new three, the other three, but we know that they're just the reciprocals of these. Cosecant is the reciprocal of sine, so it's r over y. Secant is the reciprocal of cosine, so it's r over x. And then the last one is cotangent, and cotangent is the reciprocal of tangent, which makes it x over y. Okay, so here's what makes this so different. Here's what makes it a little weird compared to just normal right triangle trig. If you are in the second quadrant, for instance, picture coordinates in the second quadrant, the x values are negative. And if the x values are negative, that's going to make cosine negative, it's going to make tangent negative, secant, cotangent. If you're in the third quadrant, the x values and the y values are negative. So that's going to make sine negative. That's going to make cosine negative. It's actually going to make tangent positive if y and x are both negative. And then finally down in this fourth quadrant, my y values would all be negative. That'll make sine negative, that'll make tangent negative. So that's the part that's going to freak you guys out because you haven't really seen sine, cosine, and tangent values that could end up being negative. Okay, so let's dive into our first problem right here. Example 1 and example 2 are going to be very similar to each other. So here's how I want you to set these up. So the terminal side contains a point at -6, 2. So you're first going to start by sketching your coordinate system. Here's the x-axis, here's the y-axis, and then plot your point. So there's -6, +2, so you've got a point right there. So our initial side is still always the positive x-axis right here, and then it says your terminal side has this point on it. So we know it's going to go through this point and then right back to the origin. Okay, so this is the initial side, that's the terminal side. That means our angle is this right here. So it's bigger than 90 degrees, not as big as 180 degrees. So here's the thing that gets weird, like I said. Your x value is a -6, and I'm just getting that off of this point right here. Your y value is a +2. Again, just getting it right off of this point. So since my x value is negative, a couple of these values are going to end up being negative, which we haven't seen yet. Now lastly, we need to get r. And r we just get by doing the Pythagorean Theorem on a little triangle like this. Okay, so r, we know that x squared plus y squared equals r squared, so we're going to use this formula right here. See, if I do this as a little triangle, this is the y value, this is the x value, and I'm trying to find r right here. So x squared would be 36 plus y squared, which would be 4, equals r squared. So that's 40. And then I know that r would be the square root of 40, since I square root both sides from here, and then I can clean that up a little bit. So it simplifies like that. Okay, so that's my value of r. So I've got x and y and r. So let's start writing these values down. So the sine of theta would be the y value over the r value. So 2 over 2 root 10. Okay, first thing that happens is that the 2's will cancel, so I get 1 over root 10. Next thing is that I'm not supposed to have square roots in the denominator, so I rationalize the denominator by multiplying by root 10 over root 10. So that would be the value of sine. Cosine, if I follow my little table up here, is x over r, which is -6 over 2 root 10. So again, this one will reduce down to -3 over root 10, because the 6 and the 2 reduce down. But again, I have to rationalize, so I multiply by root 10 over root 10. And that is my cosine value. Next is tangent. And tangent is defined as y over x. Y is 2. X is -6, so that is a -1/3. And then I've got the other three that are just the reciprocals. So cosecant of theta is just the reciprocal of sine. So I'm going to do it in this form. So root 10 over 1, which is just root 10. Secant is the reciprocal of cosine. So I'm going to do it from this form. So -root 10 over 3 is the reciprocal of this. And then cotangent is the reciprocal of tangent, and the reciprocal of -1/3 is -3. So there are your 6 trig functions for that particular angle. Next, we're going to do one that's very similar, just with a different point. So set up your coordinate system. There's the y-axis. Here's the x-axis. Contains a point at -2, 0. So there's the point on our terminal side. So that means this is our terminal side. We actually know now that this would be a 180-degree angle. So here's our angle theta. So the x value is a -2. I just get that from this point right here. The y value is just 0, and then r is supposed to be this length right here. So if all I did was go left 2 units, then r is just 2, because it's just the distance of that portion. The only reason we needed this formula up here is because it was on a diagonal, but here we can just count, and we know that r is 2 units. So same 6 values that we wanted up above. Sine of theta is y over r. The y value is 0, r is 2, so that of course is just 0. Cosine is x over r. X is -2, r is +2, so the cosine is -1. And tangent. Tangent is y over x, so 0 over -2, which is just 0. Okay, and for the other three, cosecant, Cosecant is the reciprocal of 0, or like 2 over 0, that doesn't count as anything. That is undefined. You know that we cannot divide by 0. So that means the cosecant of theta is undefined. Secant, the reciprocal of -1, is still -1. So that one's good. And then cotangent is the reciprocal of this, which would be -2 over 0. Again, we can't do that. That would be undefined because we cannot divide by 0, no matter how badly we may want to. Okay, so that's the typical example that we're going to be doing here. You set up a point, and then you can use that to figure out what all the 6 values are. The weird thing, the new thing with this section is that we can have any of these 6 come out to be negative. It all depends upon which quadrant you're in. Okay, so next definition that we are going to talk about, our next section is all about reference angles, because it makes it easier if you can reference back to like one of the main angles, like 30 degrees or 45 degrees or 60 degrees. So reference angle, we call it theta prime, that little dash, we read that as prime. So theta prime is defined as the acute angle acute meaning less than 90 degrees, formed by the terminal side of theta and the x-axis. Okay, so if your angle is already acute, then you don't need a reference angle, I suppose. So say you're in quadrant 1. Let's draw a little sketch here. If you are in quadrant 1, here's what we're dealing with. Your angle is already good to go. It's already acute. So that means if this is theta, it's actually exactly the same as theta prime. So anything that's already acute is already its own reference angle. Okay? When we are in the first quadrant, sine, cosine, and tangent, they're all positive. We don't need to worry about them switching signs, because when you're in the first quadrant, all the y values are positive, all the x values are positive, and r is a positive value no matter what. So now in the first quadrant, everything is going to come out positive. Okay, next, let's look at a second quadrant angle and see what happens there. So here's my initial side, and then your terminal side would land somewhere in the second quadrant like that. So now this whole thing right here is your angle theta, but theta prime is defined as the acute angle formed by the terminal side and the x-axis. So this angle right here would actually be theta prime. Okay, so that is your reference angle. So when we're in this quadrant, theta prime is equal to 180 degrees minus theta. So like say this whole thing was 150. This angle would be 30, and that would be your reference angle. Now, when I am in the second quadrant like this, my y values are still positive, which means sine is still positive. My x values, though, are negative, which means cosine will come out negative. And that means that tangent will come out negative, because y over x would be a positive over a negative. Okay, third quadrant. Let's look at a reference angle in there. Quadrant 3. Here's my initial side. My terminal side is going to be somewhere in there. So this whole thing right here is your original theta that you're talking about. But just this angle right here with the terminal side and the x-axis, that is going to be your theta prime. When you are in quadrant 3, theta prime is equal to theta minus 180. Okay, so if we take this whole thing right here and subtract 180, you're just going to be left with whatever that is. When I am in the third quadrant, y's are now negative, so sine is now negative. X's are negative, so cosine is still negative. And then y divided by x would actually be positive, because sine and cosine are both negative, so tangent would be a negative over a negative, which would be positive. And last situation here would be if you're in quadrant 4. Here's your your initial side. Your angle goes all the way around and lands somewhere in here. That is your terminal side. So this big thing right here is our original angle theta, but the definition is from the terminal side to the x-axis, so this angle right here is your theta prime. Now theta prime in this quadrant is defined as 360 minus theta. All right, and finally in this last quadrant, sine is still negative because the y values are negative in quadrant 4. Cosine is back to being positive because the x values are positive. And if we look at tangent, y is negative, x is positive. That makes tangent negative. Okay, so we need to know these things right here. That is very, very, very important to know for our next page. All right, so go ahead and flip. Now I want to sketch each one of these angles and find its reference angle. So plot this on here. So negative 110 degrees. Here's my initial side right here. I go backwards 90 degrees, and then I go backwards 20 more. So it would be somewhere like this. So this is negative 110 degrees. And remember, your reference angle is defined as the acute angle between the terminal side and the x-axis. So this right here would be theta prime, that angle. So what I do is I would take the difference between this angle right here and this angle right here. So that would be 70 degrees right here. Because like this little guy is 20 degrees, so what's left right here is 70 degrees. So theta prime, my reference angle, is equal to 70 degrees for this particular situation. Okay, this next one is a little weird because we are using radians, which we're not super familiar with. So one thing you can do until you have them memorized is you can always do the conversion trick. And the conversion trick between degrees and radians, between radians and degrees, is to multiply by 180 over pi. So the pi's will cancel. 180 divided by 3 is 60. So this is 120 degrees. So just for graphing's sake, to know that it's 120 degrees will make it easier for you. So 120 is like right here. Okay, so there is my real angle, my original angle, 2 pi over 3. And then you want this right here, the angle between the x-axis and the terminal side. So this is theta prime. Now, this one is different because we are now in radians. If we're in radians, we actually don't do 180 minus 2 pi over 3. We do pi minus 2 pi over 3. Okay, so what would be left here would be 1 pi over 3. Because if you combine them up, we got 2 pi over 3 plus another pi over 3 would land you at pi. So here the reference angle is pi over 3. All right, little trickier with radians. So our last thing that we're going to end on today is evaluating trig functions. So I'm going to give you guys your official step-by-step. Okay, first step is to find the reference angle theta, which we just practiced doing, theta prime. Okay, so find theta prime, which is the reference angle. Again, we just practiced doing that. Next, you are going to evaluate the trig function for theta prime. Okay, so these special values will really come in handy down here for the special triangles 30, 45, and 60, and we've got all 6 values defined here. So that's something that you're eventually going to have memorized. We'll talk about that more in class. So we define either sine, cosine, tangent, or one of the other 3 for theta prime, and then the only difference is it might be negative depending on what quadrant you're in. So next you determine the sine of the trig value. Determine the sine, and for that you use the quadrant in which the terminal side lies. Okay, so we wrote on the previous page, I'm actually just going to write it one more time for all of these quadrants. So in the first quadrant, sine is positive, cosine is positive, and that makes tangent positive. In the second quadrant, my x values are negative, and x values go with cosine. So sine is still positive, cosine is negative, and since for tangent you divide the two, you end up with a negative. In the third quadrant, both x and y are negative, so that makes sine and cosine both negative, which in turn actually makes tangent positive, because a negative divided by a negative comes out positive. And in my fourth quadrant, sine is negative because y values are negative in the fourth quadrant, but x values are back to being positive. So sine is still negative, cosine is back to being positive, and tangent will be negative. Okay, so here's a little trick to help you remember them. In here, they're all positive. In this quadrant, just sine is positive. In this quadrant, just tangent is positive. And in this quadrant, just cosine is positive. So a little acronym there. Typically, teachers will say all students take calculus, but I suppose we could say like all students take college algebra. That works for me. We'll talk about that more in class. Maybe you want to create your own acronym. Who knows? So a couple just quick examples here with example 4. We're going to go off of this and these 3 rules. So cosine of 135 degrees. I would sketch that angle out really quickly. You go 90 degrees, then you've got to go 45 more. So this is 135 degrees. Remember, the reference angle is the angle between the terminal side and the x-axis, the acute angle between the terminal side and the x-axis. And so this right here, I went 45 degrees from here to here, so that means I've got another 45 degrees to go. So my reference angle is 45 degrees. That is step 1, is to find theta prime. Then evaluate the trig function for theta prime. So now I want the cosine of 45 degrees. Okay, until we have these memorized, you can just pull them right off of your chart here. Cosine of 45 degrees is root 2 over 2. However, the only difference between the cosine of 45 degrees and the cosine of 135 degrees is that 135 is in quadrant 2. Okay, so this is in quadrant 2. And I know for a fact that cosine is negative in quadrant 2. Okay, so just a little note, cosine is negative in quadrant 2. So all I do is I either make this value positive or negative accordingly. So the cosine of 135 is actually negative root 2 over 2. And if I did it out the long way, I would be able to find that out no problem. This is just kind of a quick little trick. Okay, let's do that one more time on the next page. Tangent of 5 pi over 6. So I want you to draw in 5 pi over 6, which until we get familiar, we can always just convert really quickly by multiplying by 180 over pi. I would cancel the pi's, and I know 180 divided by 6 is 30. So this is 150 degrees. So you should know where that is. 150 degrees goes right about here. So if this is 150, the difference between 150 and 180, which is the straight line, would be 30. So that means my reference angle is 30 degrees. But we're talking in terms of radians for this one, so that would be pi over 6. All right, so my reference angle is pi over 6, aka 30 degrees, just so you know when you're looking back at that later. Second step is to evaluate the trig function for theta prime. Okay, so we want the tangent of pi over 6. So let's look back here. So remember, pi over 6 is the same as 30 degrees, so that would be root 3 over 3. Okay, and then finally determine the sine. We want to figure out what sine this should be. I'm in the second quadrant, and I know according to this that in the second quadrant my tangent values are negative. Okay, so I know that tangent is negative in the second quadrant. Okay, so that means that the tangent of 5 pi over 6 is actually negative root 3 over 3. Okay, and that is your last problem for this set of notes.